All right, here's another one. We got springs with K equals 25 pounds per foot are unstretched in this location. 50 pounds. Weight is released from rest in the position S equals S0 when the weight has fallen 1 foot. How much work has been done to it by each spring, and what is the magnitude of the velocity of the weight when it has fallen 1 foot. So work and energy released from rest. Right here, 1/2 initial kinetic energy plus the work is equal to the final kinetic energy. The work is going to be negative on both of them. Right? This one, as you stretch it, is going to pull F equals KS. And this one, as you compress it, is going to push F equals KS. So it's two of those forces acting on it, and the weight. So free body diagram, let's see, the mass, we can figure out easy, it's 50 over 32.2 pound second squared per foot. And V1 is released from rest, so that term's going to go away. V2 we're supposed to figure out, Adam I talked about. How much work has been done by each spring. So this is the work. I could set it up as two different, like the work from the top spring and the work from the bottom spring. If I wanted to make sure. F is equal to KS. So let's do this one first. And we were drawing this. Has a weight. It has F top, F bottom, and S is 1 foot. So the work, right, the force is KS. It's a function of position. So we're going to have to integrate. It's going to be W times S going down minus the integral of F, which is KS, but there's two springs, ds from S0 to S1. Sometimes we go 1 to 2, sometimes we go 0 to 1. Anyways, that's going to be 1 foot equals 1/2 mv2 squared. This is going to be mgs. And so we think the work is negative, and we think it's minus for each spring, ks, ds, 0 to 1 foot. We think it's minus 25 pounds per foot. I'll just highlight that, that's a constant. K can come outside. So I'll say integral S ds, taking the K out. So minus 25 S squared over 2 from 0 to 1 is at 1, it's 12.5. At 0, it's 0, minus 12.5 foot-pounds. That's the work done by each spring. And we're just going to get twice that right here. So minus 25 foot-pounds equals 1/2 mv2 squared. And there's no way I can get rid of the m's. So I might as well take this back from mgs to ws. 50 pounds times 1 foot is 50 foot-pounds. And so 50 minus 25 is 25 foot-pounds equals 1/2 mv2 squared, and v2 squared equals 2 times 25 foot-pounds divided by m, which is 50 over 32.2 pound second squared per foot. We've seen that this cancels out, the pounds cancel out, and we're left with feet squared per second squared. So it's just the square root of 32.2. .67 is the correct answer. That's 50 over 50 over 32.2, which is 32.2 over 50. And those cancel out. And so V2 square root 32.2, 5.67 feet per second. And this is the work each spring. Minus 12 says negative work. The force is opposite the direction of displacement. And V2 equals 5.67 feet per second. And that problem is done.